Hello, math learners! Our lesson for today is about graph of rational functions. The learning objectives are: you are expected to determine the intercepts, the zeros, the asymptotes of a rational function, and graph rational functions. This is the Learning Pocket Concept Map, and we are going to focus only on the graphs of rational function. This lesson focuses on the graphical solution of a rational function, and it is necessary to determine the asymptotes, intercepts, zeros, coordinates, domain, and the range of a rational function. The graph of a rational function is called hyperbola. And a hyperbola is a symmetrical open curve formed by the intersection of a circular cone with a plane. It consists of two curves. One of the curves is a mirror image of the other curve. The illustration is like this. So you have a double circular cone, and there is a plane intersecting the cones. And this shape, the curve and the other curve, are what we call as hyperbola. And we also have the vertices of hyperbola. Center of the hyperbola, we have the asymptotes, the broken line or the dotted lines, and the branches, or simply the graph. Here are the steps in graphing rational functions. Find the asymptotes of the rational function if there is any. Draw the asymptotes as dotted lines or broken lines. Find the x-intercept or intercepts, the zero or zeros, the y-intercept of the rational function, if possible. Then construct the table of values. Plot the points and draw a smooth curve to connect the points. And find the domain and the range. And take note, you have to make sure that the graph does not cross the asymptotes. Let us have examples on how to sketch the graph of rational function. So recall the graph of rational function of f of x is equal to 1 over x. If you can still remember, these are the values that we had last time for the table. Then, vertical asymptote x is equal to 0, horizontal asymptote y is equal to 0. There is no oblique asymptote. X-intercept none, y-intercept none. For the 0, it's none. Then the domain is equal to the set of x such that x is not equal to 0, because that's the value of our vertical asymptote. And for the range is the set of y such that y is an element of R, where y is not equal to 0, because the horizontal asymptote is y is equal to 0. So, let us have now the graph of f of x is equal to 1 over x. So, you have there the vertical asymptote, then the horizontal asymptote, and plot all the points. And then connect the points with a smooth curve. Then see to it that you have to label it completely with the y-axis, x-axis, then coordinates of the points, and see to it that you have the name of the graph. Next example, the graph of f of x is equal to 2 over x minus 3. So, the graph of the rational function f of x is equal to 2 over x minus 3 is like this. So, I will show you on how to sketch the graph. First, find the vertical asymptote. So, the solutions are, given the rational function, you have to look at the denominator, x minus 3, equate it to 0. Transpose negative 3, you will have 3. Therefore, the vertical asymptote of f of x is equal to 2 over x minus 3 is x equals 3 or line x equals 3. And how are you going to sketch? Just draw a dotted or a broken line passing through x is equal to 3. Next, find the horizontal asymptote. First solution, you have to solve for x in terms of y. So, change f of x into y and then cross multiply. Distribute y. So, you have xy minus 3y equals 2. And then transpose negative 3y. So, you have 3y plus 2. Divide by y, divide also the other side by y, cancel y, so what is left is x is equal to 3y plus 2 over y. This is now the value of x in terms of y. Next solution. Equate the denominator to 0. The denominator is y, so you have to let y equal 0. So, y is equal to 0. Meaning the horizontal asymptote of f of x is equal to 2 over x minus 3 is y is equal to 0 or line y is equal to 0 or commonly called as the x-axis. So, we're done with the vertical asymptote. So, you draw a dotted line or a broken line on the x-axis and mark it as y is equal to 0 to represent the horizontal asymptote. Next, find the intercepts. So 3.1, find the y-intercept. These are the solutions. So you have to let x is equal to 0. So meaning substitute 0 to x. So 2 over 0 minus 3, so you have negative 2/3. Divide this and get the equivalent decimal form. So you have y is equal to negative 0.67 or negative 0.7. And these are the coordinates of the point. So the y-intercept is negative 0.7. So it's here. This is the y-intercept. 3.2, find the x-intercept as well as the 0 or the root. So you have to let y is equal to 0. So by this time, changing f of x into y and change it to 0, once you cross multiply, you will have 0 times the quantity x minus 3 is equal to 2. So 0 is equal to 2, which will give us a false statement because 0 is not equal to 2. Thus, there is no x-intercept. So, if there is no x-intercept, there is no 0 or root. Because earlier, our x-axis becomes already the horizontal asymptote. So, it has no real root. Take note, the graph of f of x is equal to 2 over x minus 3 does not intersect the x-axis. It will only approach the x-axis or y is equal to 0. So here, the graph will not cross this because this is now our horizontal asymptote. That is why there is no x-intercept. Then number 4, you have to construct the table of values of the rational function. So assigning values to x from -2 to +7, then f of x, if it is -2, you have -0.4, and so on. So I will just show you one example, and for the other solutions, you can do it. At x is equal to -2, so f of -2, using the given rational function, so substitute -2 to x, what you will have is 2 over -5. Change it to decimal form, you have -0.4. So the coordinates, we have -2 and -0.4. So it's here. Then, plotting the coordinates of the point. So the point is here. So with the coordinates -2 and -0.4. For the other solutions, you can do it yourself. Then you have to plot all the points. 1, 2, 3, 4, 5, 6, 7. Plus the y-intercept. Then afterwards, you sketch the graph and label it completely. Connect the points with a smooth curve and make sure that the graph does not cross the vertical and the horizontal asymptotes. So it would be like this. Connect. Then you have there connect. And it will never cross the horizontal asymptote y is equal to 0. And also the vertical asymptote x is equal to 3. And it has no oblique asymptote because looking at the given, the degree of the numerator is less than the degree of the denominator. Then find the domain and the range. Finding the domain, the singularity is x is equal to 3 since the vertical asymptote earlier is x equals 3 or line x equals 3. Therefore, we are not going to assign 3 to x. So the domain is equal to the set of x such that x is an element of R where x is not equal to 3. And for the range, the singularity is y is equal to 0 since the horizontal asymptote is y is equal to 0 or line y is equal to 0. Therefore, we are not going to assign 0 to y. So the range, we have the set of y such that y is an element of R where y is not equal to 0. So you can use all the values of y until here, not including 0, going down. Then for the values of x, all the values here and all the values here except 3. So, let us have a summary of all the answers that we had earlier. Vertical asymptote is x is equal to 3. Horizontal asymptote is y is equal to 0. There is no oblique asymptote. No x-intercept. Then the y-intercept is -0.7. So if there is no x-intercept, so there is no 0 root. The domain is equal to the set of x such that x is an element of R where x is not equal to 3. And for the range, we have the set of y such that y is an element of R where y is not equal to 0. So, you have there x is equal to 3 for the vertical asymptote, then y is equal to 0. Then plot all the points that we can find in the table of values. And there, connect. And do not forget to label it properly. Y-axis. You have there the x-axis. The coordinates. Label properly the vertical asymptote, the horizontal asymptote. And we are done. Do you have questions? There is none. Let us have another example. Graph the rational function f of x is equal to 4x plus 1 over 2x plus 1. So this is the graph of f of x is equal to 4x plus 1 over 2x plus 1. So first, find the vertical asymptote. Using the given, so focus to the denominator and equate it to 0. Transpose 1, you have negative 1. X is equal to negative 1/2. Therefore, the vertical asymptote of f of x is equal to 4x plus 1 over 2x plus 1 is x is equal to negative 1/2, or line x is equal to negative 0.5. So, x is equal to negative 0.5. You have here the point and you draw a dotted line or a broken line passing through. X is equal to negative 0.5. So that's our vertical asymptote. Next, find the horizontal asymptote. Using the same given, so what we have, you have to solve first for x in terms of y. So change f of x into y. And then cross multiply, distribute y. You have 2xy plus y, then copy. And then transpose y, so you have negative y. Transpose 4x, negative 4x. Factor out 2x. 2x is common here and here. So 2xy divided by 2x, what we have is y. Negative 4x divided by 2x is negative 2. Copy. Then divide by y minus 2 and also the other side. So cancel. So what we have is 2x and divide it by 2. The other one, divide also the other side by 2. Then cancel 2 and simplify the other side. Take the reciprocal of 2 and multiply by 1/2. And x is equal to negative y plus 1 over 2y minus 4. This is now the value of x in terms of y. And then equate the denominator to 0. The denominator is 2y minus 4. So let 2y minus 4 equals to 0. Then transpose negative 4. You have 4. Y is equal to 2. Then the horizontal asymptote of f of x is equal to 4x plus 1 over 2x plus 1 is y is equal to 2, or line y equals 2. So how will you graph that? So the red one is the vertical asymptote. So the horizontal asymptote, you draw a dotted line or a broken line passing through y is equal to 2. And you name this as line y equals 2. That's the vertical asymptote, and the other one, the horizontal asymptote. Next, find the y-intercept. So again, we have to let x is equal to 0. And you express f of x into y form. Change x into 0 and also the other one. Then, 4 times 0 is 0 plus 1 is 1. 2 times 0 is 0 plus 1 is 1. And 1 over 1 is 1. Meaning, the coordinates of the point, we have 0 and 1. So the y-intercept is 1. So 0, 1. This is our y-intercept. Next, find the x-intercept and the 0 or the root. Given the same rational function, so by this time you have to let y is equal to 0. Change f of x into y. Then change y into 0. Then cross multiply. What we have now, 0 is equal to 4x plus 1. Transpose 4x to the other side, negative 4x is equal to 1. Divide by a negative 4, divide by a negative 4, so x is equal to negative 1/4. So the coordinates of the point, we have negative 1/4 and 0. Thus, the x-intercept is negative 1/4 or negative 0.25. If the x-intercept is negative 1/4, the 0 is also negative 1/4. And it has only one real root. The graph of f of x intersects the x-axis once. That is what we meant by one real root. So, it's here. Negative 0.250. That is our x-intercept. Next, you have to construct the table of values of the rational function. F of x is equal to 4x plus 1 over 2x plus 1. So, these are the values of f of x is equal to 4x plus 1 over 2x plus 1. So, I will show you one example. At x is equal to negative 3, the value is 2.2 or 2.20. So, solution, f of negative 3, change x into negative 3. So, there you have negative 3. Then do not forget you have plus 1, then plus 1. So this is negative 12 plus 1. The other one is negative 6 plus 1, which is equivalent to 2.2 or 2.20. And for the other solutions, you can do it yourself. As you can see, you can include also in the table of values the important points, the x-intercept as well as the y-intercept. Next, you have to plot the points and sketch the graph and label it completely. Connect the points with a smooth curve and make sure that the graph does not cross the vertical and the horizontal asymptotes. So it's here. The points are here. And connect it with a smooth curve. And still we don't have the existence of the oblique asymptote, since the degree of the numerator is equal to the degree of the denominator. So the degree is 1, the other one is also 1. We can only have an oblique asymptote if the degree of the numerator is 1 greater than the denominator. So find the domain and the range. For the domain, the singularity is x is equal to negative 0.5, since the vertical asymptote is line x is equal to negative 0.5. Therefore, the domain is the set of x such that x is an element of R where x is not equal to negative 0.5. You can assign all values of x except negative 0.5. And for the range, the singularity is y is equal to 2, since the horizontal asymptote is line y is equal to 2. Therefore, the range is the set of y such that y is an element of R and y is not equal to 2. So, the graph is like this. You can assign all the values of y here except 2. You can assign all values of x here and here except negative 0.5. Then let us have a summary of the results. the vertical asymptote is x is equal to negative 0.5. The horizontal asymptote is y is equal to 2. The oblique asymptote, it's none. Y-intercept is 1. X-intercept is negative 0.25. The 0 or the root is negative 0.25. Then the domain is the set of x such that x is an element of R and x is not equal to negative 0.5. Then R is equal to the set of y such that y is an element of R and y is not equal to 2. So, there you have the vertical asymptote, then the horizontal asymptote, then plot all the points, and then afterwards, you connect with a smooth curve. Then, do not forget, label it completely with the y-axis and then x-axis with the corresponding coordinates of the points and then the name of the graph. Questions? If there is none, let's proceed. Let us have the graph of the rational function f of x is equal to 3x squared minus 2x plus 1 over x minus 1. This is already given in the previous discussion of Mr. Baluran, wherein you can have an oblique asymptote. So I will no longer show you the solution, I will just show you the graph. So the summary of the results, we have the vertical asymptote is equal to x equals 1, horizontal asymptote none. But there is an oblique or slant asymptote which is y is equal to 3x plus 1. Then the y-intercept is negative 1, the x-intercept is none, 0, none. The domain is equal to the set of x such that x is an element of R and x is not equal to 1. The range is equal to the set of y such that y is an element of R. This is now the graph. So there, then plotting all the points and with a smooth curve. And then you label it completely. See to it that you have arrowheads of the hyperbola. Then the coordinates of the points. Then this broken line is the slant or the oblique asymptote. And here you have the vertical asymptote. And you are not allowed to assign values of x which is 1 and 4. That is why this is an open circle. Do you have questions? If there is none, let us recap. So what are the steps in graphing rational functions? First, find the asymptotes of the rational functions. Then draw the asymptotes. Then find the intercepts. Construct the table of values. Plot the points and draw a smooth curve to connect the points. Find the domain and the range. And see to it that the graph does not cross the asymptotes. Do you have questions? If there is none, then see you next time. Bye!